Your Code as a Crime Scene with Adam Tornhill.
The Azure DevOps podcast is a show for developers and DevOps professionals shipping software using Microsoft technologies. Each show brings you hard-hitting interviews with industry experts, innovating better methods, and sharing success stories. Listen on to learn how to increase quality, ship quickly, and operate well. And now your host, Jeffrey Palermo.
Welcome to the show. I'm Jeffrey Palermo, your host for helping you and your teams move fast, deliver quality, and to run your software with confidence in Azure, all while using everything that the .NET ecosystem has to offer. This podcast is sponsored by ClearMeasure, a software architecture company that empowers .NET teams to be self-sufficient and able to deliver world-class results. ClearMeasure is hiring both architects and .NET engineers who'd like a path to become an architect. So you can go to clearmeasure.com/careers for more information on that. My guest today is Adam Tornhill. He is a programmer who combines degrees in engineering and psychology, and he's the founder of CodeScene, where he designs tools for software analysis. He's also the author of several books, Software Design X-Rays, the best-selling book Your Code as a Crime Scene, Lisp for the Web, and then finally, Patterns in C. Adam's other interests include modern history, music, and martial arts. Adam, welcome to the show. How are you, sir?
Thank you very much. Really, really good to be here.
Oh, my pleasure. My pleasure. We've had other guests in the past that talk about various metrics and knowing the quality and just being able to distill information about a code base, even when you might not have participated in building it. But before we kind of dive in, just so that the guests can get to know you a little bit, if they haven't seen some of your public speaking or read some of your books, what are the key parts of your career that you think have contributed to you working on this type of problem and focusing on code metrics?
I actually think it started pretty early. So I got my first programming job in 1997, which actually means I had my 25th year anniversary as a software developer this year.
Ah, congratulations.
Yeah, and early on, I worked for some large product companies, and those early years was very much a tale of one software disaster after another. So we had projects running late, delivered with fewer features as promised, and quite often they were way over budget too. And I spent a lot of time back then trying to figure out why is it so hard to write good code. So that's where it very much started. Also had some really, really skilled colleagues that I learned a lot from. But at some point, I kind of decided that I want to dig deeper into this. I want to really, really understand why it's so hard to succeed with software, why it's so hard to write good code. And I kind of also figured out that I won't really find answers to that within the software industry. So I decided to look elsewhere. And that's where I picked up psychology. So I ended up spending 6 years at university studying psychology, and was fortunate to also work as a software developer in parallel. So I kind of had lots of opportunities to relate the two fields to each other. And that has more or less formed what I've been doing over the past 10 years.
Wow. That's fascinating. And you've written 4 books. And I want to dive into them. Do you have a 5th book in your mind that'll come out at some point?
Indeed, I do. I actually have sketches for 2 more books, and I think one of them is actually going to happen. It's been almost 5 years now since I wrote Software Design X-Rays, and I kind of started to get motivation to writing again. And it's very likely that it will happen.
Yeah. Once you get the bug, you keep on going. Fantastic.
Yeah, it's fun. I'll kind of always find that writing for me is very much a learning experience, because I sit down to write about something I think I mastered. Mm-hmm. And then when you write, you are more or less forced to take this other perspective, right, and try to explain something. And that's when I often figure out that I might not understand the topic as well as I thought I did. So I find that I learn a lot through writing.
Sure. Okay. So let's dive into, I guess, your most best-selling book, Your Code as a Crime Scene. And of course, you've you've created a company around helping people implement some things in that book. Give us your thought process. You've invoked a crime scene, meaning, okay, you're coming in, you're trying to figure out what's going on, but what's the premise and what motivated you to write that book?
Yeah, so Your Code is a Crime Scene took a lot of inspiration from the field of forensic psychology. And there's a reason for that. Back in the days when I started to explore the techniques that eventually turned into Your Code is a Crime Scene and the company CodeScene, was that I worked as a software consultant, and I consulted for some large product companies. And very often I was hired in some kind of technical leadership role, some tech lead or lead developer or software architect. And as part of those responsibilities, I found myself being that communication bridge between the business side, the product side, and the engineering organization. And quite often, business wanted to push ahead with a certain number of features that were deemed important, and they probably were. But I knew, given my technical background, that these features, it won't really be safe to do them. There's a lot of predictability if we go ahead with them because we have this particular piece of technical depth, or we lack a particular skill to do them, or whatever. So I often try to push back and say that, okay, we can do this, but first we need to refactor here, or we need to improve this part. And I simply found that having those conversations were extremely hard because software development and software code in particular is very abstract. There's no way I can really take a software system and kind of, pull it out and turn it around and inspect it for flaws and show it to a non-technical stakeholder. And so I tried to shine some light on code, and I started to use a bunch of traditional static analysis tools to gain some insights into where are the overly complex parts and things like that. But what I found is, and what everyone was found if they start to use those techniques on a larger code base, is that the problem is not necessarily to find bad code because there's so much of it out there. Mm-hmm. The problem is, of course, to prioritize based on what benefits the business. And this is a really challenging part. And at the same time that I was wrestling with these problems, I was in the middle of my psychology studies. And I took this course in forensic psychology, where I studied a concept called geographical offender profiling. And geographical offender profiling is very much about finding patterns in human behavior. So you more or less start from the crime scenes, their geographical locations. And based on the distribution of the crime scenes that you can get to the same offender, you could more or less calculate a probability surface that predicts where their home base is. So this is where I started to think about that, wow, what if we can do the same thing for code? What if we could pick up a large code base that might have a lot of complex code, and then we project this probability surface that, hey, here's the probability that you will have to work with that part of the system again. And then I kind of started to think, okay, where do we get that data? We would need behavioral data, obviously not of offenders, but of developers. And it kind of occurred to me that we already have all the data we need. We're just not used to think about it that way. And I'm, of course, referring to our version control systems that we've been using for decades, and that more or less tell the story of how our system evolved. So that's where it kind of all started.
That's fascinating. My wife loves crime scene TV shows and murder mysteries or detective stories, even books. And so as you're saying it, you're right. They focus on the behavior of the offender and what they might do again. That's interesting. Okay, so you're analyzing their version control history. Is that where you get all the data, or do you also crawl the actual code?
So I actually crawl the actual code because we do need to get some insights into the source code. So basically the way it works is that my version control data, because in version control data, I can get information on what of the system are we working with regularly. Mm-hmm. How frequently do we modify the different parts of the code? And what happens when we do that? Is the code getting better or worse? So that kind of gives me the whole relevance perspective. But then, of course, you can have parts of the system that you work on all the time. Those parts of the system, they are really, really clean. They are nicely architected, right? So they are not really a problem. And to be able to make that judgment and say, okay, this part of the code that we work with, is it a problem or not? Then we do need an understanding of the source code. And this is something I've done a lot of work on over the past year with trying to automatically measure things like how healthy the code base is.
Okay.
So it's basically an intersection between relevance and a quality perspective.
When I think about code metrics that I think a lot of people have read about, you hear about things like cyclomatic complexity and then lines of code and coupling from one assembly to another. But what kind of results does this process yield? So
traditionally, I would say very little, because cyclomatic complexity, I think, is a perfect example. So it's a really, really old metric, right? Mm-hmm. It was defined in 1976 by McCabe. And it's a very widespread metric. The problem with it is that it's hard to explain to software developers what it actually is. Mm-hmm. And it's even harder to explain how it can be relevant to a non-technical stakeholder. I think the main value I see in metrics is as a communication tool. And cyclomatic complexity is pretty poor at that. And then if you deeper into the actual research on it, you also find that the moment you start to control for metrics like the number of lines of code, cyclomatic doesn't add any further predictive value. And that's kind of where I start to think about there must be something that's better than just lines of code, right? And the interesting thing with code quality is that, and code complexity in general, is that for all these 25 years that I spent in the software industry, it kind of occurred to me that everyone really knows that code quality is important. Mm-hmm. But it's kind of knows within quotation marks because no one ever had any data to show it. So that's one thing we have been on lately to see, can we actually measure the business impact of code quality?
Okay, so if you're measuring this, what kind of units is the measure? What does your measure look like?
So what we did was that we used an aggregated metric for code quality. I'm not a big fan of the word code quality because it kind of suggests an absolute, whereas reality is often way more complicated. So what used is a metric that's called code health. And it's an aggregated metric based on roughly 25 different factors that you can measure in the source code. So things like brain classes, God functions, copy-pasted logic, overly large modules, things like that, 25 factors. And then you weight them together and you end up with this normalized value that you can put in 3 different categories. So you have perfectly healthy code. That's where you want to be. Then you have the code in the middle that has started to accumulate some technical debt, has some design issues, and you know it's problematic. And then you have what I call red code, which is the code that is a nightmare to work with. It's really, really expensive to reverse it. So that's what we use for the kind of the quality dimension. What we then use to estimate the business impact is that we actually started to measure the time in development. So we measured how long does it take to make changes, being out a new feature or bug fix, and how does that correlate to the actual code health?
So in my mind, or my past experience, there's probably more than 2 phases, but one situation where you're coming into a code base and you're just trying to get the lay of the land. And the other is when it's actively being developed and a team is trying to make sure that their code doesn't become unwieldy and low quality. So is the process different in each of those situations?
I think it's slightly different. I think it's basically the same metrics I would use, but I would use them in a different way. So when I want to onboard myself in a code base that I'm not familiar with, I rely a lot on the behavioral aspect. So I want to measure things like hotspots that I talk a lot about in your code as a crime scene. Which parts of the code are actively developed? Where is most of the development activity? And I can use that to kind of guide my onboarding, because I know that if something is very actively worked on today, then it's likely to be a central part of the system that I need to be familiar with. And the good thing with hotspots is that they usually don't make up more than 2, maybe 3% of the code base. So that kind of constrains what I have to learn. And then I also want to figure out about different things, like dependencies. So if I touch this part over here, be it a subsystem or a significant module, what other parts of the code am I likely to come in touch with? Third and final thing I would like to look at is the knowledge distribution in the code base. Basically, who worked where and who has the most experience in a particular area, and that can help me a lot to know who I need to communicate with. Whereas if I have an existing code base and we as a team will look to optimize what we do, then I'm not as interested in absolute numbers. What I'm most interested in is trends. So are we moving in the right direction or the wrong direction? So this is something I want to have as a feedback loop every single day. Speaking
of feedback loops, and just glancing at the product, and talk a little bit about this CodeScene, because of course you can implement this for yourself, but you have a product that can save teams a lot of time to implement it. It supports 35 some odd languages, which C# is one of the top supported languages. But when someone makes a change, submits a pull request, and then there's somebody who needs to review that pull request and decide whether it's good. What's your thought process, and how did you design CodeScene to aid in the pull request process?
Yeah, so that's an interesting area. So my experience from working with all these companies is that pull requests and code reviews in general are extremely valuable. There's a lot of research that points that out. But they also tend to become a bottleneck in practice. So it turns out that the people who spend most of the time reviewing code, they are very, very often overloaded with pull requests. So anything we can do to kind of simplify that and prioritize which code you need to look at is valuable. So what CodeScene does is that, first of all, we automate a couple of things. So when you open a pull request and you have CodeScene in the loop, CodeScene is going to do an automated code review for you. And it's going to look at these code health factors to make sure that you don't degrade the code. So we're not using absolute threshold for that. What we're doing is that we use the temporal perspective. We look at the trend and make sure that you leave the code at least as good as you found it. The second thing that we do is that since we have all this history from both how the code evolved and from the version control history, we can also do a risk prediction where we can simply figure out that, okay, the way this change looks, it looks very similar to a commit that actually introduced a bug in the past. We can kind of also recommend a review level based on the estimated risk and say that, hey, this is a pull request that you should look much, much deeper at. Whereas another pull request is something that maybe you can just do a quick inspection and roll it through. So there are like these two aspects that we help out with the code review process and the risk assessment that help us prioritize. And if we do that, then it frees time so that we can focus on, the most important thing of the pull request that cannot really be automated, like, are we implementing the right thing in the first place?
Many thanks to our podcast sponsor, ClearMeasure. ClearMeasure is a software architecture company that empowers clients' development teams to be self-sufficient, moving fast, delivering quality, and running their systems with confidence. Whether starting a new project or developing new technologies or techniques, ClearMeasure sets up your team to deliver world-class results. Learn more at www.clearmeasure.com. ClearMeasure, empowering software delivery.
You mentioned that previous code that might have introduced a bug, you find similarities. How do you know that a particular commit introduced a bug? How do you glean that?
It's an interesting task to piece that information together. Basically, what we do is we integrate a third data source, which is typically some kind of product management tool like Jira or Trello or Azure DevOps, right? And if you do smart commits, that is, you have some kind of mention of your tickets in the commit message, then we can actively go to, let's say, Azure DevOps and figure out that, okay, this particular change, that was a feature, where this was a bug fix. And for there, if you know that something is a bug fix, then you can easily trace it back and say, okay, those lines, they were introduced in this particular commit. It doesn't work for all bugs, but I would say like for 98% of all bugs, you have the information that you need there.
Wow. Okay, so CodeScene not only integrates with your version control repository, but also your work tracking tool, or some of the work tracking tools.
Yeah, actually we do. We started with that line of work a couple of years ago because what I found after writing Your Code as a Crime Scene was that these metrics, they very much resonated with engineering community.
Mm-hmm.
It really, really helps us understand existing code and helps us prioritize which technical debt we need to pay down. But it was still pretty hard to kind of communicate that to management. So what we wanted to do was to put this business perspective on top of it.
Mm-hmm.
And the best way we found to do that was simply to integrate with this product management tools and fetch information about what type of work do we do, how long are our development times. And again, I think that the main value is in the trends. Because if we make any change, be it that we pay down some tech debt or we reorganize or we change our process, then we want to have a measurable outcome. I really think that's valuable.
That's a really big issue with a lot of people adopting code analysis in general is just going into a code base that already has things wrong, and they look at a big daunting task of, do I really have to fix everything that this tool is complaining about just in order to get value? But you mentioned that the tool makes sure that you left the code at least as good as before. That to me is huge. I'm interested in how you actually figured that out. But if you're analyzing the commit history, then that makes sense.
Exactly. And actually, I learned that the hard way as well, because I remember my first client when I had just founded CodeScene back in 2015. I went visiting them. And prior to my arrival, they had used a static analysis tool to try to quantify their technical debt.
Mm-hmm.
So they've taken this tool and thrown it at their 15-year-old code base. And this tool happily reported that on your 15-year-old code base, you have accumulated 4,000 years of technical debt.
Wow.
I mean, it's a huge number, right? And one can easily argue that it might even be a correct number, because a lot of that probably grew by having hundreds of developers working in parallel, right?
Mm-hmm.
But it's not particularly actionable. It's not particularly useful. It's depressing at best.
Yeah.
That's why I always say that there's so much more signal in trends. And since we have the version control data, we can easily figure out if something is getting worse or better. And that's what I like to think we can drive behavior with and make a positive change.
So how would there's so many tools out there in the market and so many options. You've got, of course, the in the .NET world, the Roslyn analyzers. You got a static code analyzer for pretty much every language out there. And then you got commercial products like SonarQube and Independ in the Microsoft space. And then, of course, what was it? The I'm blanking on the name. Some security analyzers that integrate with Azure DevOps. Does CodeScene? Do you think that it plays well with certain other products, or do you, when you recommend an implementation, is it mostly CodeScene instead of the other products?
No, I think that other products can be a very nice complement. So I'm still using static analysis tools and code analyzers, but I find them valuable as a low-level feedback loop while writing the code.
Mm-hmm.
This is basically what these tools are good at. That's what they're optimized for. What those tools aren't good at, and they were never intended for that is to prioritize existing technical debt. And that's where CodeScene comes in, because that's one of the big things you can get by taking this behavior perspective on code.
Mm-hmm.
Then there's the other factor that on a larger project, and with larger, I would say that, somewhere about 20 people on a project, social factors like knowledge distribution, how we're organized into teams, and how well those teams fits the architecture and the way system evolves. It's at least, if not more important than any properties of the code. So this is another aspect that you can really only get by looking at the behavior of the organization and overlay that social layer on top of your code. And I haven't really seen any other tools that do it in a way that we do at CodeScene. So that's where I think that these other code analysis tools, they are a very nice complement to what we do. But if I wouldn't view them as any replacement. Mm-hmm. But I'm, of course, obviously biased.
Well, I don't think it's a bias. I think here's someone who spent 2.5 decades kind of pouring themselves into this problem and trying to help the industry solve a particular problem. That's really good. That's valuable perspective in my book. Uh, now, if someone is building a software organization and they're in the process of determining how many developers, when to split into two separate teams versus one larger team, and how to put the code base together, what things can they do right from the beginning? What rules of thumb have you learned where you would recommend, some of those rules for people just getting started? They don't have the big legacy code base that they're trying to investigate as a crime scene. They're on the verge of either creating a new crime scene or creating this lovely, wonderful software ecosystem, and they need to go down the right path.
Yeah, so that's a pretty good situation to be in. And there are a couple of things I would recommend. First of all, to keep the organization as small as possible, as long as possible, is very much valuable.
Mm-hmm.
Because we kind of all knew this from the fifth man month, right? That at a certain point, our coordination paths, they are going to kind of explode with the individual that we had. So the fewer people, the less communication.
Let's pause and plug the Mythical Man Month, because you and I probably read that in schooling, but a lot of new developers haven't read Fred Brooks's book and his series of essays, the most popular of which being the Mythical Man Month. So I'll put that in the show notes and agree with you that everyone needs to have read that. But please go on.
Yeah. And then there are a couple of general recommendations I would like to give. So what I always look for in a team are two things. First of all, I would like the team to be cohesive. And what I mean by that is that everyone in the team, they pretty much should work on the same parts of the software. If they don't, then it's very often a sign that the team doesn't really carry a meaning from an architecture perspective, most likely because they're working on multiple things within the team. So it's more like an artificial boundary around the number of individuals. The second thing I look for is to have very weak dependencies between teams. You do want teams to kind of know about each other. You want them to collaborate every now and then. But in general, that becomes really, really expensive. And to make all of that work, because that's the trick, it's not only a purely organizational change. To make it work like that, you also need to have a software architecture that supports that way of working. And this is where, unfortunately, I've seen many organizations go wrong. You start out with something like component teams. It doesn't work for you. You get extremely long lead times. Then you switch over to feature teams with the idea that now a team can implement something end to end. But unless your architecture supports a clean separation between different, that you're going to shift your bottlenecks into the whole system becoming a bottleneck. The whole system basically becomes a gigantic coordination points for your different feature teams. So keeping this balance between your software architecture and your teams, it's really, really vital.
Yeah, good points. Since you mentioned software architecture, what is your preferred method of delivering or communicating the architecture? The series of diagrams, things written on paper, certain diagram types. How do you think about that?
That has actually changed a little bit over the years. I used to be pretty big on diagrams. I kind of enjoyed sketching things out. But I found lately that I kind of turned more and more to having this preference for written decision, for having like architectural decisions written down in a form of logbook. And I often find that those notes, they communicate just as much about architecture, if not more, than the static diagrams. And what I'm using today is a combination of that. And then, of course, we also have CodeScene that we use for CodeScene itself. So we can kind of always visualize what the actual architecture looks like. And that's also an important aspect.
Wait a minute. You said that CodeScene also visualizes what the existing architecture is?
It does. It does. We need to help it a little bit because CodeScene, in some cases, CodeScene can actually figure out, if you point it to a repo or multiple repos, CodeScene can sometimes figure out that, okay, this is your architectural style. But most of the time, we need to help it a little bit. So we get a map of our system, the different files are visualized. And what I can do now as a user is I can tell CodeScene that, okay, the files over here and the files over here, they are part of this particular component or this package or this service.
Mm-hmm.
Then CodeScene will scale the analysis to the level of architecture and kind of show the dependencies between them and stuff like that. And that's what I found useful, because if I look at that and I understand the desired software architecture, then I typically look for surprises, because a surprise is simply one of the most expensive things you can put into a software architecture. So anything that kind of violates my expectations about the architecture typically deserves a deeper dive.
Fascinating.
So that's what I meant.
Well, as we wrap up here, we'll include the things we talked about in the show notes. What's for listeners who are really intrigued and want to kind of jump in? What are the steps to implement CodeScene for their code base? What do they need to do?
Oh, it's pretty simple. So we have a free community edition at codescene.com. And there's also, if you have proprietary software, you can also run it for free for a month. And all you need to do is you need to have your code at a Git hosting platform like GitHub, Bitbucket, GitLab, Azure DevOps. And the only thing you need to do is you simply point CodeScene to your repositories you want to analyze, and then you press a button. And that's pretty much it. And what I think is important is that while these mechanics are simple, information is only good when acted upon. Mm-hmm. So when I work with the team, I always kind of recommend that, with the tool CodeScene, you shouldn't have to work differently. You shouldn't have to do something different. You kind of just need to find these natural collaboration points where you can bring up this information and make sure that everyone in your team is aligned. They have the same situational awareness. So for a typical team, it's things like planning retrospectives, and of course, having it in the pull request reviews is valuable in my perspective.
All right. Well, again, we'll include that in the show notes. And Adam, hey, thanks so much for coming on the show and giving us your perspective and talking about your book, Your Code is a Crime Scene, and of course the software that kind of built out of that learning. As you mentioned, when you write a book, you mostly learn for yourself in a deeper fashion. So anyway, I appreciate you coming on the show and sharing with us.
Thank you. I really appreciate that. And thanks a lot for having me on the show. It was truly my pleasure.
Oh, you're very welcome. You're very welcome. And until next time, keep shipping.
You've been listening to the Azure DevOps Podcast, a show for developers and DevOps professionals shipping software using Microsoft technologies. Go to www.azuredevops.show for show notes and other episodes. On behalf of your host, Jeffrey Palermo, and our sponsors, thanks for listening, and may God bless you.